So the first one that we're going to take on is the compound angle concepts. So the compound angle identities basically. Now the kind of questions that are asked, our objective is going to be firstly take on the types of questions that are asked and take some of the recent past exam questions and that are really challenging. So the compound angle formula that we got to study in our HL syllabus is basically the cos A plus B formula, cos A minus B, um, sin A plus B, sin A minus B, and of course the tan A plus B, uh, tan A minus B formulas. And then after that, there are double angle and half angle formulas. So double angle and half angle formulas. Now, what exactly are these formulas? These all are in your data booklet, so nothing to worry about. But just if it is, in case if you can remember them, it is always good. So like cos A plus B is cos A cos B minus sine A sine B. That's the formula for cos A plus B. Then if it is cos A minus B, cos A minus B is cos A cos B plus sine A sine B. And after that, you got the other one, which is sine A plus B. So sine of angle A, cos of angle B, plus cos of angle A, sine of angle B. So it's just see the difference. Be careful about the sign issues that you get. Now, the next up is sine A minus B is sine A cos B minus cos A sine B. The tan formulas I would derive from here. So just in case if it can be remembered that they're derived from sine A plus B over sine A minus B, sine A plus B, cos A plus B, sorry. And what we get is a formula that is tan A plus tan B over 1 minus tan A tan B. So this is a basic formula. And tan A minus B, the only difference that you notice is that it is tan A minus tan B over 1 plus tan A tan B. So that's the formula for the compound angle formulas. And their direct usage is actually very, very interesting. So like sometimes what they do is that they will give you the value of cos A. For example, cos A has been given as let's say 3, 4, where angle A is in quadrant number 1, which is 0 to pi by 2. And let's say I have given sine A, which is, let's say, negative 1, 4, and where angle B is in sine B, which is in the 4th quadrant. So let's say it is in 3 pi by 2 to basically 2 pi. So this means that this is the first quadrant, this is the second quadrant. And what they ask us to do is they ask us to calculate the value of let's say tan A plus B, for example. Hence, find out the value using these values. Find out tan A plus B. Now, what will be interesting here is to actually apply the formulas. Like, let's say if I have got an angle, obviously in second quadrant. Now here it is that tan A. Let's say this is A. Cos A is 3, 4. So adjacent side is 3 and hypotenuse is 4. So with this, you can get the opposite side, which is root 16 minus root 16 minus 9, basically, which is root of 7. And then you can predict the other ratios. Now, what you could do is you could use identities also for finding the ratios. Like, let's say I could use simply sine square A plus cos square A as 1 to find out, let's say, value of sine A in case if you need it. You could use the other identity, which is 1 plus tan squared A is sec squared A. Then 1 plus cot squared A is cosec squared A. So these are identities can be also used instead of a triangle. Okay, so now for example, if I've got to find out the value of tan because I need tan A, I could just use the second identity that helps me a lot. So what I can do is I can say 1 plus tan square theta is sec square theta. Sec is nothing but the reciprocal of cos, which is nothing but 4 over 3 the whole square. Now, just a little bit of mistakes that kids make is that if you got sec squared A, it is nothing but sec A the whole square. That's how it is. It is not like sec A squared. Now here you're squaring the angle and then you're finding the ratio. So it's completely different what you say in these three things. So just be careful about that. Now, coming back to the problem here, what we have is we have to find out the value of tan A plus B. So now you can just apply the formula here. So I can solve for tan squared A is going to be 16 over 9 minus 1, and then you can find the value of tan A in case. So you'll get the same answer as this, which is root 7. So the value of tan A is a root 7 over 3. So from here that you get, and just be careful that in which quadrant it is. If this would have been second quadrant, you would have taken this as a negative. So because in second quadrant, the ASTC rule, that is ASTC, all ratios positive, sine positive, tan positive, and cos positive. So that's really important out here. So you're going to do this now. So tan A plus tan B over 1 minus tan A and tan B. So that's your formula that we have written here. So that's the one which we're going to use. So we got tan A already. We got to find the tan B. Now, since I've got sine B already here, so I'm just going to draw. For the position of this second angle, which is fourth quadrant. Now, since sine is negative, don't get overwhelmed with this minus sign. It just is like to help you with the quadrant, which quadrant it is. Then the opposite side is 1. The hypotenuse is 4. So this is going to be root of 15 in this case. So what you get is, when you find out the value of tan B, actually it is going to be 1. So this is the B angle, let's say, if I take. So tan B is going to be 1 over root 15. But since it is in fourth quadrant, you can see that only cos is positive. So that's what you are going to take this as negative. So what you get is tan B is negative 1 over root 15. So what you get is eventually, yes, 1 second.
Nothing, got it.
Okay. So tan A you get is basically root 7 over 3 here. And tan B is you get is negative 1 over root 15. So you just substitute here and simplify. So you get the value. So this is one way, this is a one type of question that IB asks, like where you actually reflect upon each of the component, like how we did here, and then put in the formula. And the second type of question that is asked is basically around the double angle and the half angle. So let's first go over the double angle. So if I just write down the first formula, cos A plus B and sine A plus B. So when you look at cos A plus B is cos A cos B minus sine A sine B. Second one is sine A plus B is sine A cos B minus plus cos A sine B. So what I do is in these two formulas, if I take, let's say, A equals to B, so what I do is if I replace B with A, so eventually what we get is cos 2A is actually cos squared A minus sine squared A. And if I put here sine 2A is going to be sine A cos A plus cos A sine A. So this is nothing but 2 times sine A cos A. So these are the basic double angle formulas. And obviously what you notice is that if you have the angle 2 times here, it becomes 1 times here. And if you have like twice of the angle, you can see it becomes single angle as this. So when you're finding out, let's say, cos of 4A, like let's say cos of an angle which is 4 times A, it is cos squared 4A minus sine squared 4A. Sine squared 2A, sorry, cos squared 2A minus sine. So whatever is the angle that you have, it becomes half of that. Similarly, if you got sine of 4A, it can be written as 2 times sine 2A and cos 2A. So that's the basic stuff. The half angle formula is, let me just first write down the other forms of cos 2A. The cos 2A's other formulas can be 2 cos squared A minus 1 and 1 minus 2 sine squared A. So these are the 3 formulas that we get. If you replace cos square A with 1 minus sine square, you get this one. And if you replace sine square A with 1 minus cos square, you get this one. So these are the 3 formulas for cos double angle, and only 1 formula for sine double angle. Now, what are the half angles? Half angles are equally important for your calculations. So we'll be doing, let's say, one problem on half angle as well. So what is half angle basically? If you got cos A is cos squared A over 2 minus sine squared A over 2. So it's basically what happened is that the values that you get here, the values that you have, half of that value, so that is here. And so same, it goes as 2 cos squared a over 2 minus 1, which is 1 minus 2 sine squared a over 2. And in case if it is sine a can be splitted as 2 times sine a over 2 cos a over 2. So these are some of the, and the double angle formula for cos 2a I'm using is 2 cos squared a minus 1, so that this 1 get cancelled basically. So once you get cancel this 1, so that's my LHS. One of the cos goes, 2 goes, and then the answer is actually tan a. So that's how you basically prove this one. Now there's a question. There's actually an IB exam question, and they say that find out the value of cot pi by 8. So how do we use this identity? Hence, when we say hence, find the value of cot pi by 8. So how do you find out the value of cot pi by 8? So now what we can do is we can just, if I put tan first, so if I put, let's say, a as pi by 8 here, so I get sine 2 times pi by 8 over 1 plus cos 2 times pi by 8, which is sine pi by 4 over 1 plus cos pi by 4. And this is nothing but 1 over root 2 divided by 1 plus 1 over root 2, because this value sine pi by 4 is 1 over root 2, cos pi by 4 is 1 over root 2. So this answer is 1 over root 2 divided by root 2 plus 1 over root 2. So this cancels. And now since we got tan pi by 8 as this, to find cot pi by 8, we are going to take just the reciprocal of this, which is nothing but root 2 plus 1. So some of the usage of the double angle formulas can be like really interesting. So let's take some more example now. So with this example, what we have to find out is find out the value of cos 4x. Now they have given us that sin x plus cos x is 2 over 3. Using this relation, find out the value of cos 2x. Now cos 4x. Now this becomes really interesting. Is basically lots of times you'll get sin x plus cos x is like, generally they'll give this kind of question. Sin x plus cos x is like something like, let's say, a, find the value of the double angle. So in this case, your strategy should be straight away squaring both the sides. So let's see, if I square both the sides, sin x plus cos x, if I square both the sides, what do we get? So if I square both the sides, let's see, we get sin squared x plus cos squared x plus 2 sin x cos x, and equals to 4 over 9. So that's your, this particular answer. Now here we get is 1 plus sine 2x is basically, since this part is 1, sine squared x plus cos squared x is 1, and 2 sine x cos x is sine 2x, which is 4 over 9. So sine 2x from here, what we get is 4 over 9 negative 1, which gives me negative 5 over 9. So since we have got sine 2x, now we got to find out the cos 4x value. Now cos 4x will be basically, it'll be 2 cos squared 2x minus 1, or I could use 1 minus 2 sine squared 2x. For me, using this one is more like, is better because I already have sine 2x value. So what we do is we just put 1 minus 2. Now, lots of kids write down like this. So they make a mistake of sine squared of negative 5 over 9. This is absolutely incorrect because sine 2x is basically negative 5 over 9. So what you do is actually just write down the square of negative 5 over 9. So what happened is this become 1 minus 2 times 25 over 81. And if you simplify that, you get 31 over 81. So that's how you basically do this particular question. Now, this general mistake, we got to be very careful because if you lose this, you're actually losing at least like 2 to 3 points. So this really important is to make sure that you don't consider this sine square as separate and 2x as separate. Because since here we got sine 2x already, sine squared, remember that sine squared x is same as sine x the whole square, and it is not equals to sine of x squared. This is absolutely important. So for this question, what we have is we have to prove that, let's say, in triangle ABC, 3 sine B plus 4 cos C is equals to 6, and 4 sine C plus 3 cos B is 1, and we have to show that the sine B plus C is equals to half. So what we do in this case is that the squaring logic always helps. So you square both the sides here. So if I square both the sides, we get the first one we get is 9 sine squared B plus 16 cos squared C plus 24 sine B cos C. sine B and cos C equals to 36. Similarly, square the second one, which is 16 sine squared C plus 9 cos squared B cos C plus 24 are the same form. So what we do is, now if I look at this, coefficient of sine x here is 5 and coefficient of sine x here is R cos alpha. So R cos alpha equals to 5. And second is, here you can see minus here, and you got R sine alpha equals to 12. So you got coefficient of cos x here is R sine alpha, and here is negative 12. So this equals to R sine alpha equals to 12. Now, to get the exact value of R, what we do is we use the elimination of alpha, which is by squaring both the sides and adding them. So it'll become R squared cos squared alpha plus R squared sine squared alpha equals to 5 squared plus 12 squared, that is 169. And if you take the left hand side and take R squared common, this is 1 in the bracket and 169. So that gives me R as 169 root, which is 13. The next part is to find out the value of alpha. Now, since we got this, now you can put either R in this form here, or you could just divide this and this. So what happens is that if I divide R sine alpha with R cos alpha, both the sides, if I divide 12 over 5, R and R get cancelled. We get tan alpha is 12 over 5, and that is nothing but tan inverse of 12 over 5, which is 67.4. That's the acute angle. And since they have mentioned already that alpha is acute angle, you don't need to find the other angles. Now, basically, so this form, which we have written now until this part, I can replace R actually with, so alpha is 67.4, and R can be replaced as the 13. So the same form, and if I plot this, or if I plot this, you will see that they are the same graphs. So this is important to understand this interconversion. Sometimes it is with sine, sometimes it is comparison with the cos. So, so this is the entire procedure to find out the particular equation in this format. The next part is to solve the equation 5 sine x minus 12 cos x equals to 7. So now when you solve this, instead of using this one, what we do is we use the second format that we got. So that is nothing but this 13 sine x minus 67.4 equals to 7. So that gives us sine x minus 67.4 equals to 7 over 13. Now what we're going to do is we're going to solve for this first, for this angle. So since the ratio is positive, it'll be either in first quadrant or second quadrant. You could just directly use calculator also. So you could plot this graph, you could plot this graph and see where they're intersecting, since it is a calculator question. But sometimes this answer that you expect they get is like in terms of the like 1 over 2 or something, and then in that case you have to use this unit circle. So what we do is we get this angle with 32.6 when you find out the sine inverse of 7 over 13. The other angle will be 32.6 as well. So when you write down the value, it will be x minus 67.4 is equals to 32.6. That gives me x as 100. Or second answer will be x minus 67.4 is 147.4, which is nothing but this angle, or you can see this angle here. So that gives me x as 214.8. So these are the two answers that fit into the 0 to 360 range. Now, the next part is to find out the maximum value of this. Now remember that the maximum value, for finding maximum value, you can't directly use sine and cos. Like, okay, sine maximum is 1, cos maximum is 1, hence the maximum will be 5 minus 12, the whole square. No. For this, what we do is we use just this back formula, which is 13 sine x minus 67.4 squared of this. So it'll be 13 squared sine squared x minus 67.4. Now, since you know that sine, this value will oscillate between 0 to 1. Any sine squared value will oscillate between sine, because this is not moving up or down. So it's just only sine function taken right 67.4 and then square it. So if I square it, my range of this value will be between 0 and 1 sine square value. Since they are asking for the maximum value, if I take any decimal value, the value of that will further make it smaller. So the maximum value is actually 169, because if I do 13 square times 1 is 169, and minimum will be 13 square times 0, which is because the lowest value is 0. So that gives me 0 as the answer. So here what we have got is basically the two acute angles that they've given, A and B, that are cos ratio for that is 2/3. Sine ratio is 1/3. You have to find out this value and show that this comes to this particular answer. So here what we do is, I'm just going to first show what is the need of the double and single, compound angle. So what we do is, if I expand cos 2a plus b, it is going to be cos 2a cos b minus sine 2a times sine b. Now we have got sine b already, so I need cos b. So in case of the basic angle, so we can say this is 1, this is 3, and this is going to be basically root of 8. So for me, cos b is nothing but root of 8/3. Now next up is the cos a has been given as 2/3. So we have to find out the cos 2 and sine 2a. So cos 2/3 is actually, cos a is 2/3. So we'll first find the sine a. So this is 2/3. Let's say this angle A, this is 2 and this is 3. This is going to be root 5. So sine A is root 5/3. So we find out the value sine 2a because we need sine 2a here. So sine 2a is 2 sine A cos A, which is going to be 2 times sine A is basically, here we got is root 8/3, root 5/3, and cos A is basically, we have got is 2/3. So that becomes 4 root 5/9. Now, similarly, find out the value cos 2a. Cos 2a can be written as 2 cos squared A minus 1. So it is 2 times cos squared A is going to be this, which is 2/3 the whole square minus 1. So it is 2 times 4/9 minus 1. So this is 8/9 minus 1, which is negative 1/9. So cos 2a is negative 1/9. And so we put the values here. So cos 2a is negative 1/9. Cos b is root 8/3. And minus sine 2a is, we got is already here, which is 4 root 5/9. And cos sine b that we got is basically the value sine b is sine b, which we got is nothing but 1/3. So we got this answer. If you simplify it, you get this particular expression. As far as the inverse trig is concerned, what we got to understand is the basic key concepts of the function. For finding inverse function, for sine, that is sine inverse, or also it is referred as sometimes arc sine x, or cos inverse. For cos x, it is cos inverse x, also referred as arc cos x. So what we're going to do is, we're going to first understand the basic, the domain and range restrictions for this. Now, what we assume is that you understand the basic sin x graph. So the basic sin x graph is actually starts from origin, that is here, and it goes like this. And this side it is with the negative cycle, which is here. Now, since you can see that the graph doesn't pass the horizontal line test, we have to restrict the domain. And for finding the inverse, we restrict the sin x domain from basically from negative pi/2 to pi/2. So this is the part that we restrict. And now, as a result of that, what we get is we get the function being 1-to-1 now. So what you remember is that the principal domain that we restrict the sin x for is actually from negative pi/2 to pi/2. And the range for which sin x we restrict is negative 1-to-1. And obviously, when you sketch the inverse of this, the domain and range switches. So this is the function that is the inverse function. So for inverting functions, the range becomes domain, so negative 1-to-1. And this part becomes, the domain become negative 1-to-1, and the range become negative pi/2 to pi/2. So we get this particular graph, and what I recommend is that remember this, because sometimes it is very helpful that if you just remember the sine inverse X graph, and there can be some inequality based questions that can be solved directly. So you remember that this value is 1, and this is -1. This is pi by 2, and this is negative pi by 2. So logically speaking, similarly for cos x, what we have is we have the restriction from 0 to pi. The cos x graph generally is like this, both the sides. It's an even function. So what we do is we restrict the graph from basically from 0 to pi. And obviously, if you sketch the inverse of this function, it becomes something like this, which is here is pi, and this point is negative +1, and this is -1. So the domain of the cos inverse function is -1 to 1, and the range is 0 to pi. So that's how you basically remember these. And the last one is a tan inverse graph. So tan inverse graph is basically, we just take one cycle that is from negative pi by 2 to pi by 2. And it's inverse when we draw across y equals to x line. So the inverse that you notice that it is going to be something like here, which is nothing but the reflection in y equals to x line. And in that case, the range that you get is negative pi by 2 to pi by 2. And the domain is x belongs to real number. Now, sometimes you'll notice that there is capital arc and small arc. So if you take this principal domain that we took minus pi by 2 to pi by 2, it is referred as a capital arctan. In case if I would have restricted, let's say this cycle, if I would have rejected this part and I would have taken this cycle, still I could have got the inverse. In that case, it is not the principal domain. So you refer as small arc. So these are the basic graphical interpretations. So first, let's take one question that is linked up with the graphs of this inverse trig function. Now, for this particular question, what we have to do is we have to first find out the largest possible domain. Now, since we know that the square root is not defined for negative values, so the condition here is pi by 4 minus arc cos x, arc cos x is more than or equals to 0. So that becomes basically pi by 4 is higher than arc cos x. Now, since we get an inequality like this, what we do is that the interesting is to actually sketch the graph and then find out the answers. So first we're going to do is sketch the R Cos X graph, which is, that's why I told to remember the basic R Cos X graphs. It is from here. It starts like this. It's positive 1. Here it is -1. And you take, let's say, pi over 4 here. This is pi over 4. Now you can see that the graph I want is where is R cos x below pi by 4. Okay, so so R cos x below pi by 4. So below pi by 4 is happening only in this range that you can see. So what we'll do is we'll first find this intersection. So equate R cos x with pi by 4. So you get cos x, x equals to cos of pi by 4, which is 1 over root 2. So this answer is 1 over root 2, and you can see that the final answer for this will be from 1 over root 2 to 1. So that's the domain of this particular function. So for inverting function, like the B part is to find inverse and write its domain. So what we do is we have got y is root of pi over 4 minus cos inverse x. Bring this other side, interchange x with y first. That's pi by 4 minus cos inverse of y. And then cos inverse of y is pi by 4 minus x squared. So y is basically cos of pi by 4 minus x squared. So this we get is the general, like, you know, the function, but we have to specify its domain and range very explicitly. Now, since we know that the domain of the original function becomes the range for its inverse, and range becomes the domain. So what we'll do is we'll first find out the the domain for the domain, what we are basically doing is we are finding out the range of this function. And since we got the domain of the function that we're taking here, which is 1 over root 2 to 1 over root 2 to 1, that's the domain that we've taken here. So what we do is you plug this 1 over root 2 value here and then you plug 1 here. So you'll get the range of the original function between y between 0 to pi root pi over 2. That's the range of the original function, and that also becomes the domain for its inverse. So the domain for its inverse will be basically x between 0 to root pi over entire pi over 4 you can do, or root pi over 2. Now, so the problem solving on the sine inverse, cos inverse, or tan inverse involves questions like you have to basically evaluate, let's say, sine of 2, let's say tan inverse of half. You have to find this value without any usage of calculator. Now, what is really important is that some of the properties that you've got to remember is that tan inverse of any thing that is an angle. It's always an angle. So remember that this is not in ratio, it's an angle. So what I'm doing is basically I'm finding out tan sine of some 2 times some angle. So I take this as this angle is basically, let's say this angle be A. So for me, let tan inverse of half is basically A. And what actually I'm finding out is sine of 2A. So sine of 2A is something I'm calculating. So it'll be 2 sine A cos A. So now 2 sine A. Now, firstly, if tan inverse of half is A, so tan of A is half from here. And what we get is you draw the triangle. So that gets A. This is A, and so this is 1 and 2. So this becomes root of 5. So sine of angle A is actually 1 over root 5, and cos of angle A is 2 over root 5. So what we do is basically 2 times 1 over root 5 times cos A is 2 over root 5. So that becomes 4 over 5. So this value without using, we could get it.
So we can.
Now, another interesting formula and question that is most of the time is asked is on prove that, let's say if I have to prove that tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y over 1 minus xy. So firstly, in some cases you take this as a formula, and in some cases this can be a problem itself. So what we do is, in this case, what we do is, let's say I'm just taking LHS. So I take, let's say, let this be angle A, this be angle B. So if I take tan inverse of x as some angle A, tan inverse of y as some angle B, if I could find out the value of A plus B, that's what is my objective. So if I take A plus B, so let tan inverse of x plus tan inverse of y, let tan inverse of x be A, tan inverse of y be B. So our objective is to actually get the value of A plus B. And if this comes out to be this, that proves identity. So what I do is I just take, instead of taking A plus B, I take tan of A plus B. So that is nothing but tan A plus tan B, tan A plus tan B over 1 minus tan A tan B. Now since tan inverse of x is A, so x is tan of A and y is tan of B. So what we do is we take tan of A plus B actually is equals to tan of A is x plus y over 1 minus xy. And if you bring this tan other side, what we get is A plus B is tan inverse of x plus y over 1 minus xy, which we wanted to prove. So this is the general formula that we can take to evaluate some of the questions like find out the value of tan inverse of half plus tan inverse of 1/3 or something like that. So when I do tan inverse of half plus tan inverse of 1/3, I get tan inverse of half plus 1/3 over 1 minus half times 1/3. So what we get is tan inverse of 5 over 6 divided by 5 over 6, which is tan inverse of 1, which is pi over 4. So this is a general logic to do these kind of questions. So to find this value, what we basically do is we first take out these two, we pair them together. So tan inverse of half plus tan inverse of 4/3. So that's going to be 1/3 plus 4/3 over 1 minus 1/3 times 4/3. And plus, what you could do is you could first find out 2 tan inverse of half. That is, I could write down this as tan inverse of half plus tan inverse of half. So that can be written as tan inverse of half plus half over 1 minus half into half. So that becomes tan inverse of 1 over 1/4. So tan inverse of 1 over 3/4 actually. So that becomes tan inverse of 4 over 3. So once you get this, we are going to use along with this one. So I will just simplify tan inverse. So this is pi over 3 divided by 9 minus 4, which is pi over 9. So plus tan inverse of 4 over 3 here. So what we get is this 5 and 5 will get cancelled, and we get tan inverse of eventually 3 plus tan inverse of 4 over 3. And once again, if we do the formula application, we get tan inverse of 3 plus 4/3 over 1 minus 3 times 4/3. And you can just simplify this. So say sometimes we'll say that write down this answer in terms of tan inverse of k, and where k is a rational number. So just k out here, if you simplify, that's the value you get.